distributing divided method, we can use the Lagrange interpolation of a polynomial for it. So we've been using Lagrange and we've not been able to do it successfully because of time, because you guys have not been joining and those stuffs. So today, please, let's do this successfully. The exam is here already. So here I have a question that says f of 1. Okay, we've treated this particular question. The question I'm going to look at, the one I wanted to look at in the last class, which we couldn't finish then, was x is given, f is given. And there are recordings as well. So I have x 1.2, I have 1.7, I have 1.8, and I have 2.0. I have 3.3201. I have, please, can you hear me? Hello, can you hear me? Kingsmate. Okay. Please, if you can't hear me, let me know. Okay, Eze, what's it, please? She raised her hand. Okay, this is what we have here to do. So we are going to use Lagrange interpolation formula to find the value of f when x is equal to 1.4. What this means is that we are given the values, but we don't even know what the polynomial is. By ourselves, we have to create the polynomial here. After we create the polynomial, we now get the value of f when x is equal to 1.2. We know that when x is equal to 1.4 rather. We know that when x is 1.2, this is the value. When x is 1.7, this is the value of f. When x is 1.8, this is the value of f. When x is this, which is 2.0, this is the value of f. Now we want to know the value of f when x is 1.4. But before we could do that, we have to create a Lagrange polynomial first, interpolation polynomial. So to do that, we know that our Lagrange interpolation polynomial p of x must be equal to 0 Lagrange, that is L0 of x, times f0, plus first Lagrange of x times f1, plus second Lagrange of x times f2, plus third Lagrange of x times f3. The thing is, we've talked about this thing before. So this formula we wrote here, we've even used it if you watched the recorded videos. So here we just need to know, we need our L0, we need our F0. Here, my X0 means the one that starts it. That is 1.2. My X1 means the one that follows it. That is 1.7. My X2 is the next one, 1.8. My X3 is the next one, 2.0. So my F0 is going to be this, the one under 1.2. My F0 will be 3.3201. My F1 is going to be 5.4759. My F2 is going to be 6.0496. And my F3 is going to be 7.3891. Now, I have my F0, I have my F1, F2, and F3. I need to have my L0, L1, L2, and L3 now. So what is my L0 of x? We said if we are going to get stuffs like this, my L0 of x is going to be equal to x minus x0. I'm supposed to write x0, right? But because I'm looking for the 0 Lagrange, L0 of x, I am going to omit 0. So x minus x1 times x minus x2 times x minus x3. Now I now need to use that 0 here because it is. Can you guys see it? Please, can you see the screen? Is it showing, please? It's not really showing well.
It's blurry.
Can you see it? Kingsmith, is it?
It's blurry.
Oh, Kingsmith, can you see it from your own end? Maybe the.
I can't see it.
Kingsmith, you are just reacting. Which one is like? Is it you can see it, or you cannot see it?
I can see.
Yeah. Maybe the recorded one will help, guys. And okay, maybe they don't know. Please pin my own name. Pin my name. You should still be able to see it at least. Pin my name. Oh. Pin salary. So the next, then all over x0, because we are looking for L0x. So x0 minus x1 times x0 minus x2 times x0 minus x3. This is the case. Then the next thing to be done is going to be this. So this now equals, what is the value of x given to us? They said find the value of f when x is equal to what? 1.4. So I'm now using the value of 1.4 now. 1.4 plus x. What is my x1? 1.7. So that's 1.4 minus 1.7. Open bracket. X minus x2. That is 1.4 minus, what is x2? 1.8. Open bracket. X minus x3. That's 1.4 minus, what is x3? 2.0. All over x0 minus x1. What is x0? x0 is 1.2 minus x1. What is x1? 1.7 times x0 minus x2. x0 is 1.2 minus x2 is 1.8 times x0 minus x3. That's 1.2 minus x3 is 2.0. So what we have now is 1.4 minus 1.7. Your calculator will help you with these. 1.4 minus 1.7 is minus 0.3 times 1.4 minus 1.8. That's minus 0.4 times 1.4 minus 2.0. That's minus 0.6 all over 1.2 minus 1.7. That's minus 0.5 times 1.2 minus 1.8. That's minus 0.6 times 1.2 minus 2.0. That's minus 0.8. So if you took your calculator out to do the workings here, I believe I'll be having this now, cancelling. Please, you can take your calculator. What you want to do is 0.3 times 0.4 times 0.6. Me, I don't have calculator, so I have to depend on myself now. I'm having this, so I'm going to have 0.2. So 0.2 times 0.3, that's 0.06, all over 0.5 times 0.6, that's 0.03 as well. So this is equal to 2. I'm having the value of L0 to be equal to, L0 of x. I'm having the value to be equal to 2. Or I don't know. Am I wrong? Is there? Please let me calculate it there.
Yeah, you're right.
Is there anyone with calculator now?
It's 2. You are right.
It's 2. Thank you. Thank you. So the next thing will be L1 of x. L1 of x is the next thing. And that's going to be x minus. Now I'm going to jump L1, right? X minus x0. So instead of writing x minus x1, 2, I won't write that because I'm talking about L1 of x. So I jump to x minus x2, then x minus x3. All over x0, that was what we used there. Now we'll be using x1 because we're talking about L1. So x1 minus x0, we'll not be writing x1. x1 minus x2, we'll jump the x1, that's what I mean. Times x1 minus x3. So here is the case. What is x? X is 1.4 minus x0. x0 is 1.2 times x minus x2. That's 1.4 minus x2 is 1.8 times x minus x3. That's 1.4 minus x3 is what? 2.0 all over. Please mute your mic, Eze. x1 minus x0. What is x1? 1.7 minus x0. x1 is, yes. So 1.7 minus x0 is 1.2 times x1 minus x2. That's 1.7 minus 1.8 times x1 minus x3. That's 1.7 minus 2.0. So this is equal to 1.4 minus 1.2, that's minus 0.2 here, times 1.4 minus, no, 1.4 minus 1.2 is the same as 0.2, not minus. 0.2 times 1.4 minus 0.8, that's minus 0.4, times 1.4 minus 2.0, that's minus 0.6, all over 1.7 minus 1.2, that's 0.5, times 1.7 minus 1.8, that's minus 0.1, times 1.7 I'm going to be having this one here, one, this 2. So I'm going to be having minus 0. Your calculator can do it. 0.2 times 0.4. That's going to be 0.08 times 2. That's 0.16. That's minus 0.16 all over 0.1 times 0.1. 0.5 times 0.1. That's minus 0.05. So this is going to give me 3 points. Your calculator will help you with all this I'm doing here. This is going to give me 3.2 as the value of L1 of X.
Yeah, 3.2 is correct.
Now we need L2. All right. Okay. So we need L2 of X now. We've got an L0 of X, L1 of X. So L2 of X now is going to be X minus X0 times X minus X1. So there will not be X minus X2, right? So X minus X3. It's because I'm talking about L2 of X. Now all over X0, it will now be X2 now. X2 minus X0 times, the reason I'm emphasizing on this thing is that it's even many of the questions we encounter, not a lot of them. So X2 minus X1, there will not be X2 minus X2, right? So X2 minus X3. So this is going to be equal to, what is X? X is 1.4 minus, what is X0? X0 is 1.2 times X is 1.4 minus X1, that's 1.7 times X is 1.4 minus X3, which is 2.0 all over X2 minus X0. What is X2? X2 is 1.8 minus X0, which is 1.2 times X2 minus X1. That's 1.8 minus X1, which is 1.7 times X2 minus X3. That's 1.8 minus 2.0. So that is going to be 1.4 minus 1.2. That's 0.2 times 1.4 minus 1.7 minus 0.3 times 1.4 minus 2.0 minus 0.6 all over 1.8 minus 1.2, that's 0.6. 1.8 minus 1.7, that's 0.1. And 1.8 minus 2.0, that's minus 2. No, minus 0.2. So what we have here now is, Mr. Alison is not here again. He's the one who only calculates here. So what we have here is 0.2 times 0.3 times 0.6. So this is going to give me minus 0.6 cancels 0.6. 0.2 cancels 0. Cancels minus. I'm having 3 as my answer here. The answer here is L3x. And what is L3x? That's going to be x minus x0 times x minus x1 times x minus x2. I'll not be writing x minus x3, right? All over x3 minus x0 times x3 minus x1 times x3 minus x2. I won't be writing x3. So is equal to, what is x 1.4 minus x0 is 1.2 times x 1.4 minus x1 is 1.7 times x 1.4, this one is not 3, it is minus 3. 1.4 minus x2, which is 1.8 all over x3, which is 2.0 minus x0, that's 1.2 times x3, 2.0 minus x1, 1.7 times x3, 2.0 minus x2, 1.8. Then we are having 1.4 minus 1.2, that's 0.2, times 1.4 minus 1.7, that's minus 0.3, times 1.4 minus 0.8, that's minus 0.4, all over 2.0 minus 1.2, that's 0.8, times 2.0 minus 1.7, that's 0.3, times 2.0 minus 0.8 minus 1.8, that's 0.2. Having this as the case, we are going to have the value of L3x to be 0.4 here, 1, 0.4 here, 2, 0.2 cancel 0.2, 0.3 kills 0.3. Having the value to be 1 all over 2. That's the answer here. I'm having L3x to be 1 all over 2. So we can now return and use the formula we are meant to use, or that's meant to use. And what is the formula? The polynomial is going to be equal to, that is P of x, and that's going to be f. That is the polynomial f we are looking for. They said find the f when x is equal to 1.4. We've taken our x to be 1.4 already. So what is our f? P of x is equal to f is going to be L0 of x times f0. What is L0 of x? That's 2. L0 of x was gotten to be 2. That's going to be 2 times f of 0. What is f of 0? 3.3201. So we have 2 times 3.3201 plus L1 of x. That is what? L1 of x is 3.2 times f1. F1 is 5.4759. 5.4759 plus L2 of x. That is, L2 of x is minus 3 times F2, 6.0496 plus L3 of x, which is 1 over 2 times f of 3, f3, that's 7.3891. That being the case now, we can get the value of our P of x, which is equal to f when x is equal to 1.4. The first one is 2 times 3.3201. That's going to be 6.6402. 6.6402 plus the next one is 3. I cannot calculate this with my head. 3.2 times 3.2 times 5.4759. 3.2 times 5.4759. That is 17.52 plus the next one is, okay, that one is having minus. That's going to be minus 3 times 6.0496. 3 times 6.0496. That's 18.15. Then plus 7.3891 times 1/2. That's divided by 2. The answer is 3.695. That's 3.69. 3.70. So f is given now to be the addition of all this, the sum of all this together. That's this value plus 18.15 plus, oh, it's not plus 18, it's minus, let's go gently. 6.6402 plus 17.52. I prefer using it in 2 decimal places. Minus 18.15 plus 3.69. Of f. As the value of f, I have 9.7002. If there was no mix up under any circumstance. The first one is this. There is no mix up anywhere. So I suppose we have our stuff right. 3 points. So the first one, let's calculate this one again. 2 times this. The value is 2. Yes, it is it. Yes, 2 times 3, unless it is not 2. 0.03. Let me use this calculator. 0.3 times 0.4 times 0.6, 0.072 divided by 0.5 divided by 0.6 divided by 0.8, 0.3 times, the answer here is 0.3. 0.3. So it is that 0.3 we'll be using with this 0.3 as the F1, as the L1 of X. So 0.3 times 3.3201. 0.3 times 3.3201. That's 0. Sorry about that. So the calculator is giving me 0.996. So that was my own manual calculation error. 0.996 now plus 17.52 minus 18.15 plus 3.69 equals 4.056. So this is the perfect value of x, of f, when x is equal to 1.4. The thing is this way. This exact question, in fact, might be asked in the exam. So you just need to know the method, know what you want to do. Try to do it in exam and you assure yourself of scoring 1 mark higher. If it's 2 times, 2 marks higher. So that's that about the normal interpolation for Lagrange. If it is ordinary, we have inverse polynomial, inverse interpolation as well. This is ordinary interpolation. We are given the x. We are asked to look for the f. Now, in some cases, they might give us the f and ask us to look for the x. It might come that way too. So as for this is what it is. So show everything. Then we proceed with inverse interpolation. No, interpolation. So, Kingsmate, are you still with me? Any question from anyone first? Anybody with any question? Any question? All right, that being the case, let us talk about inverse interpolation. Okay, so we are going to be talking about inverse interpolation now. Just a minute. Wasn't holding the phone for me now. I want to do something. Just a minute. Abdullah, Usman, yeah. Sorry about that. The person holding the phone for me wants to do something. Okay. So now let us talk about inverse interpolation. In inverse interpolation, our x will act as y, and our y will act as x. So let's say you have this problem from the following table. This is the table x, y, I have 1, 1. Then 19, 3. Then 49, 4. Then 101, 5. So the thing is, from the given table, find the Lagrange's interpolating polynomial which agrees with the value of x at the given values of y when the value of y is equal to 2. Now, we are given y to be equal to 2. We are looking for x. This is the issue now. We are given y to be equal to 2. We are looking for x. So what we need is going to be p of y, which is equal to the x we talk about. And it is equal to L0 of y times f1 or x1 plus f0 rather, L1 of y times f1 plus L2 of y times f2 plus L3 of y times f3. So how do we go about this? My L0 of y, as we all know, is going to be y minus y0 will not be there, right? So y minus y1 times y minus y2 times y minus y3 all over y0 itself minus y1 times y0 minus y2 times y0 minus y3. But what is my y1? My y1 is equal to 1. My y2 is equal to 3. My y3 is equal to, my y0 is 1. Sorry. Start from 0. My y0 is 1. My y1 is 3. My y2 is 4. My y3 is 5. So what is my f1? My f0. My f0 will serve as the x now. My f0 is 1. My f1 is 19. My f2 is 49. And my f3 is 101 from the table. So what is L0 of y? That's going to be y minus y1. We are already given the value of y to be 2. Find the value of x when y is equal to 2. So that's Y minus Y1 means 2 minus, what is Y1? Please mute your mic. 2 minus 3 times, please mute your mic. Y minus Y2, that's 2 minus, what is it? Please mute your mic. Y minus Y2, what is Y2? Y2 is 4 here. Times Y minus Y3, that's 2 minus Y3 is 5. All over Y0 minus Y1. What is Y0? 1. Minus, what is Y1? Y1 is 3 times Y0 minus Y2, that's 1 minus Y2 is 4 times Y0 minus Y3, that's 1 minus Y3, 5. So it's equal to 2 minus 3 minus 1 times 2 minus 4 minus 2 times 2 minus 5 minus 3. That's equal to minus 6 all over 1 minus 3 minus 2 times 1 minus 4 minus 3 times 1 minus 5 minus 4. So this is minus 1 times minus 2 times minus 3 will give me minus 6. All over minus 2 times minus 3 times minus 4 gives me minus 24. So the answer for L0Y is going to be minus 1 over 4. You can take it to decimal place as well. That's minus 0.25. So L1 of Y now is going to be what? Ly of 1 is going to be Y minus Y0 times Y minus Y1 will not be written, right? So Y2 times Y minus Y3 all over Y1, because I'm talking about Y1, minus Y0, I'll jump Y1, right? Y1 minus Y2, Y1 minus Y3. This is equal to Y minus Y0. What is the value of my Y? Light went off again. What is the value of my Y? My Y is 2. So 2 minus Y0 is 1 times Y minus Y2, that's 2 minus Y2 is 4. Y minus Y3, that's 2 minus Y3 is 5. All over Y1, which is 1, minus Y0, Y1, which is 3 rather, minus Y1 is 3. Y0 is 1 times Y1, 3 minus Y2, which is 4, times Y1, 3 minus Y3, which is 5. This is 2 minus 1 times, 2 minus 1, that is 2, times 2 minus 4, that is minus 2, times 2 minus 5, that's minus 3. All over 3 minus 1, that is 2, 3 minus 4, that's minus 1, and 3 minus 5, that is minus 2. So this is going to give me 12 all over 4. And the answer of Ly1 is equal to 3. We need L2Y now to be equal to Y minus Y0 times Y minus Y1 times Y minus Y3, because I have to jump the Y2, right? All over Y2 minus Y0. I'm talking about Y2 now. Y2 minus Y1 and Y2 minus Y3. I have to jump the Y2. So this is equal to now Y minus Y0, that's 2 minus Y0 is 1, times Y minus Y1, that is 2 minus Y1 is 3, times Y minus Y3, that's 2 minus Y3 is 5. All over Y2 minus Y1, that is 4 minus Y1, Y0 rather, 1, times Y2 minus Y1, that's 4 minus Y1 is 3, times Y2 minus Y3, that's 4 minus Y3, 5, is equal to 2 minus 1, 2, times 2 minus 3, minus 1, 2 minus 5, minus 3. All over 4 minus 1 is 3, times 4 minus 3 is 1, and 4 minus 5 is minus 1. Now, what do we have? We have 2 times 1 times minus 3. 2 times minus 1 times minus 3. That's going to give me 6 all over 3 times 1 times minus 1. That's minus 3. So L2y gives me minus 2. Now, the last is L3y. L3y is going to be y minus y0 times y minus y1 times y minus y2. No y3 this time. All over y3 minus y0 times y3 minus y1 times y3 minus y2. This is equal to y minus y0, that's 2 minus 1, times y minus y1, that is 2 minus 3, times y minus y2, that's 2 minus 4, all over y3 minus y0, y3 is 5, so 5 minus y0, 1, y3 minus y1, that's 5 minus 3, and y3 minus y2, that's 5 minus 4. This is giving me 2 minus 1 is 1, times 2 minus 3 is minus 1, 2 minus 4 is minus 2, all over 5 minus 1 is 2, 5 minus 1, thank you very much. She was taking it. Thank you. So 5 minus 1 is 4, 5 minus 3 is 2, 5 minus 4 is 1. So this is now minus 1 times minus 2 times 1. The answer is 2 all over 4 times 2 times 1. That is 8. So I have L3y to be 1 over 4. That's 2 in here, 1, 2 here, 4. So now I can now remember my formula that my x is going to be P of y, right? That is L0 of y times F0 plus L1 of y times F1 plus L2 of y times F2 plus L3 of y times F3. So what is L0 of y? L0 of y is minus 1 all over 4, according to this, times F0. F0 is 1 plus L1 of y, that is 3, times F1 is 19, plus L2 of y, that is minus 2, times F2, 49, plus L3 of y, that is 101, times L3 of y is 1 over 4, times F3, that is 101. So now I have minus 1 over 4 times 1, that is minus 1 over 4. That's minus 0. Let's be writing it as minus 0.25 plus 3 times 19, that's 57, plus minus 2 times 49, that's minus 98, plus 101 divided by 4, that's going to give me 25.25. So what I have now is 57 plus 25.25, that's going to give me 82.25. 82.25 minus 0.25, that's going to give me 82 gerege. Then 82 minus 98 will give me minus 16. That means the value of my x is going to be minus 16. It's going to be minus 16. This is an example of inverse interpolation. So this is an inverse of this is an example of inverse interpolation. So any question from anyone? I'm going to end the class now. Any question from anyone? Any question from anyone?
Ali, please, sorry, can you come back again with your I'm not seeing. I tried to the last calculation, please. Yeah,
With
just repeat the
everything
last
or
calculation.
what?
No, not every. The last calculation where you have minus 0.25 minus 0.25 plus 57.
Okay. 3 times 19 is 57, right?
So yes,
So minus 1 over 4 times 1 is 0.25. Plus 3 times 19 is 57. And minus 2 times 49 is minus 98. Plus 101 times 101 divided by 4. That's 25.25. So the thing is now divided by 4. Yeah, is correct. Minus 0.25. I added first. Let me add 57 plus 25.25. That's going to give me 82.25. Then I now subtracted this 0.25 from it. 82.25 minus 0.25. That is 82. Now 82 minus 98. That is minus 16. That's how I got my minus 16.
Okay. Thank you. Yeah. Thank you. I guess it now.
My problem. Any other problems? Okay, that being the case, please let's have a nice time. Mass 281 is coming now. Thank you very much.